We're going to spend a little bit of time now looking at columns and beams, and we'll be applying columns to the grid, and we'll also be applying beams to the grid. There's no point really in having a grid set up and some levels set up if you don't actually use it. Now, it doesn't have to be exactly on the grid. We can offset from the grid, or we can offset objects from the grid to the right or the left hand side. So all of these things are achievable, but when we place them on the grid, or host them on the grid as it's referred to, then any movement to the grid will affect the positioning of the object or its hosted element. Doesn't really matter what it is. Objects in Revit have to be hosted on something, whether it's levels, grids, lines, objects. So you'll find more out about that as we move through the software. A couple of things you need to be aware of, and that's to do with the views in Revit. They're all independent of each other, and that's why you can only have one view per sheet. So in our level 0 floor plan, all our little bubbles are sitting on the left hand side, lined up. Level 1, however, we've got that sort of instance where they all need to be swapped over. So even though I did them in one view, I need to repeat the action for each corresponding view. So sometimes it's better to get them right in the first instance. So I'll just do this one so you get the hang of clicking these buttons. There's nothing too onerous about that. The other thing you have to be aware of, sometimes they don't line up with the levels, because you can't really see one without the other. So it's always worth checking your levels. So I'm going to the east elevation. The only reason I jump to the east elevation is because it's at the top of the stack. It doesn't matter which elevation you go to, but I'll select one of these grid lines, and because we've got that sort of 3D locking going on with them and the blue dotted line appearing down there, we'll just click this little blob and drag these things out to that point. We probably don't need them to go all the way across to there. But then if we look at the east view, we would assume that the west view is the same, and luckily it is. The north view, however, might be different, and it is. So the north view looks nothing like the east or west. So I'll drag that like that, and I'll drag that like that. I've got a little beam in there, I'll just get rid of that. And instead of going to the south view and doing the same thing, if I select all these levels, and then I go Propagate Extents, and I'll pick Elevation South, and OK, that's going to do that for me. So I'll go back to my south elevation now, and everything's looking just as it should. So propagating extents means to send the extents of these level lines to the other views, spread them, propagate them in those views so they look all the same. So now we've got our grid nicely set up. You might want to pull these down just a little bit more. We can start looking at adding columns and beams. Now you can do this in 3D or you can do it in 2D. My personal preference is to do it in 2D. You just have to be aware that we've got one level from ground to first, and then from first to second, that's second level, and then from level 2 to level 3. So we've got instances where we can stop or start a column. We could take a column all the way from ground to level 3, 12 meters high, or we could make them up to this point or this point. Depends on how we want to build this thing. Now ultimately, as the engineers of the future, you will be assessing this and discussing these things with architects and designers and coming up with the optimum solution for the design. But for now, we'll just assume that we'll take some concrete stuff up to level 2, and then we'll finish off with some steel up to that level. And again, we'll do a similar thing with some beams. I'm not doing all of it, I'm just showing you the principles. That's what these videos are intended for, and some of the little pitfalls that you might come across. So if I go to level 0, and I will go to my structure tab and go to column, and it defaults to this piece of steel, so I've got a universal column there, and that's all we get. Now if you wanted a different type of column, we could load family. Okay, so we'll click on load family, and you get this often throughout these green ribbons are the sort of context ribbons, as I would have mentioned before. And you might think that columns is the place to go to because you're putting a column in, but in fact, if it's going to be a structural element with some analytical information, then we need to go down to structural columns. So I'll double click on this one. And we got concrete, light gauge steel, precast concrete, steel and wood. So the difference between concrete and precast is made in a shop and poured on site, basically. So we'll go for concrete, and we'll go for a rectangular one as opposed to a square one, because I want to show you the slight difference between the two. A square one only has one value because it's square, so you adjust that breadth value and it'll give you a square depending on the size. Concrete has two different values. So if I click on that and then open, we then get a concrete rectangular column. Now we get a couple of options. We get 3 by 450, 450 by 600 and 600 by 750. Now what happens if we want something that's different? Well, before we go into it, we can click on Edit Type, and we get to the Type Properties editor. Now this is a similar thing that you would find if you're in the family editor of this. You could go into Type Properties and create as many different types as you wanted, and then these would come in with the rectangular column. Now we've got two values. We've got the breadth and the height for it. Okay, so not the vertical height, but the sort of plan height of it. So 300 by 450, these are the ones that we can see in the property browser. If we go duplicate, and we'll call this, we maybe want something that's 350 for whatever reason by 600. So 600 millimeters, and then OK that. That's just not going to change it just because we've called it that. So in fact I've called it 330 by 600. Never mind, that might be something more specific. So in the width or the breadth 330, and then in the height value 600, and then we can say OK. So we've changed the width and the height, and then we get something that's slightly longer and slightly narrower. Now to position it, I can rotate after insert. Okay, this thing here, rotate after placement, or I can tap the space bar on my keyboard. That's going to rotate it as well. Now if it's not going to be a 90-degree rotation, then rotate after placement might be useful, or you could rotate it using the rotate tool after you've positioned it. Another thing that you get access to is the at grids. So maybe you wanted all these columns to sit on the intersection of each of these grids, and if that was the case, it's quite easy to do. You select the at grids, ignore that, and then you click and drag over all the grids, and that's going to place a column at all those intersections. I'll cancel out of that. The other thing you need to be aware of is this thing here. So height and up to level 2. Now sometimes you get depth. I think by default you get depth and unconnected. So it's going down from the level that we're in, level 0. It's going down 2.5 meters into the ground. So make sure that says height if you want it to go up, and make sure that if it is to be connected to a level, you select the level it's going to be connected to. So level 2 will be fine. Room bounding comes in later on if you do some analysis, but a column could define the edges of a room. So again, that could be useful. This at grids feature isn't available if you decide to put a slanted column in, because it's going from one point across to another point, and the first click is level 0, and this is an offset value, -2500, so we wouldn't want that. The second click is going up to level 2. So if I wanted to put a slanted beam in from that position to that position, remember it's coming up and across at an angle, then that's the way I would do it. But I'm going for a vertical column. I will say at grids, and I'll click this selection of grids. So it's just going to go into this position, and then I'll say finish. And then I'll hit the modify button, or I can hit escape twice, and that's going to put these columns in at this position. Now if I want to rotate these, I can select, tap the space bar, and I can still rotate after I've put them in. Okay, so that's another option. If I wanted to not use the column tool but just copy them, then I can say maybe select these two columns and use the copy function. So this is just copying them, and I'll copy them from that insert point, and I've got some options. I can constrain them so they're locked in that direction, so I'm not going to sort of move them off grid, and I can click on multiple if I wanted more than one copy. So I click there, I'll click there. So I've got 3 sets of those. If we check out the 3D view, then we can see what we've got. So this is down the side, and then these are the copies that we've created. So again, if we look at it from the top view, come round, that's where our plan view was based on. So I'll just click back to that. And this is more like what we're looking at, so the top 3/4. So now we're going to put some beams in. And again, there's the connection between a column and a beam can look different depending on the type of material that you're going to use, and also depending on the type of symbolic representation or the cutback representation that you have specified. Now it might all sound a bit strange at the moment, but I'll just show you what it all means, and it's not too complicated. So if I go to level 1, so I'm going to put my beams in at level 1, so I'll put some concrete beams in, and then at level 2 we'll put some steel beams in across here. So level 1, we can still see these at level 1. Because we're showing detail level at fine, if I change my detail level to coarse, then the steel columns kind of disappear. You don't get to see much of them, and especially in elevation they just look like lines. So just be careful if you can't see something. Just be careful that this thing is turned on to medium or fine, so you can see it. It's not so much of a problem with the columns, but the beams can sometimes cause a bit of an issue. So structure and beam this time, and we've got universal beam, so I'm going to want some concrete beams, not the UBs, and there's no concrete beam to choose from, so I'm going to load family, and I go down to structure. Now there's no structural beam thing, so I go into structural framing. That's where the beams are kept. Double click and concrete, and then we've got concrete rectangular, so we'll use that same thing. It's just the orientations changed, and we say OK. And the only thing really that's driving this rectangular beam is its profile. So this one's a 400 by 800. Now, as we know how to modify these things, we'll just say that 400 or 300 by 600, that's better. I'll take that one. So it's going to sit inside of this. So we're on placement plane, level 1. Structural usage, automatic. We could call it something else, but I'm not an engineer, so I don't really understand precisely what the significance of these things are, but I guess I know what a joist is and a purlin and a girder are, but we'll just keep it to automatic, so it'll probably assume what it is from its object state. And to position it, we'll go from not the edge point, but because the analytical model will want all these nodes connected, so the connection for the column is going straight down the middle, and the analytical object, you can just see it as a blue line across the top of there, that wants to connect to the analytical line of that. So even though I'm going to draw it from this point across to this point, if we actually look at it, the visual look stops at that point, doesn't come into this one. Now because I'm on level 1, we can just see it grayed out, and the reason it's slightly grayed out is because it's sitting just below level 1, but these columns are designed to show up even if they are below the depth of the level. And again, Revit has lots and lots of visual controls that take some time to get used to. But if I take you into the north elevation, then we can see this column, and we can see that the column is actually stopping at this point and this point. To see this in its solid form, because we can only see things that really are down to this line due to the view range, we'd have to make sure this was moved up slightly. So if we wanted to do that, then we could choose an offset value. So if we knew this to be 600, then we could put our start level offset at 600. And then be careful it doesn't jump to this cross section one, because it tends to do that. And then 600 for the end, and apply that. And this is going to move this up. So all we're doing, this is the analytical path of that beam, but we've just moved it relative to this reference plane up by 600 mil. Okay, so if I go back to my floor plan, level 1, we can see it a bit more clearly now, because it's not sitting beyond that sort of level line, and so affecting the way in which it's displayed. If I wanted to put a steel beam this way, then I'll go back to the beam and we'll pick the standard steel beam there, 305 by 165 by 40, and I'll click at that intersection point, and I'll come down to this intersection point, and I'll say OK to that. And again, this is slightly grayed out because of its position. You notice we can't select it either because it's sitting underneath. Now the only way we can select underlay objects is if I turn this thing on. So I've just turned that on, and now I should be able to select that beam and then move it up. Again, start level, let's go 500. We don't have to do this, and we should really think about adjusting our view range settings instead, and I'll cover that at a later date. But 500, 500, and apply, and now we can see it. So what we get is a situation like this, where there's a slight cutback. Now if I change this, just for argument's sake, to a universal column, like so, then we get some options. And if I rotated this through 90 degrees, then this often happens. Okay, and you might want this to come in and be fixed to the flange. So if we select this beam, then we can choose this option, change reference, and we click on the middle point of it, and it just sends that to a sensible distance inside. So all of these things are easily adjustable. So if I selected this now and tapped, then it's spun around through 90 degrees, but it's saying cannot keep reference of jointed end. So reset reference, and so it pushed it back to that point. It's fine that side, but for this side you've got two different options, either up to the web or on the flange. Okay, so positioning columns and beams isn't that difficult. You set the grid up and you choose which column and beam type you want, and then you just make sure you've got the right levels sorted out. We will be going through this in class at length, but I just wanted to give you a little aid memoir when you get home, when you've got your homework to do, so that you can just recap on some of the stuff that you might not have been too sure about. So back to the 3D view. Now we can see what sort of stuff we've got. Now at this sort of level you wouldn't put in any detail, you just make sure that the sort of references are fine. If I wanted to see just the analytical model, then if I turned on this thing, because we're in an architectural template, so we don't automatically get the analytical sort of view. So if I revealed these things, we can see the analytical nodes and we can see the analytical paths across here. So the analytical model would show all of these things as a stick diagram, but we'll see more of that in the structural template. For now we'll just call it quits at this point, and I'll leave you to have fun playing with beams and columns.